Hi, welcome to our channel of IGNOU audiobooks, Indira Gandhi National Open University, School of Computer and Information Sciences, SOCIS, Diploma Programme. Postgraduate Diploma in Computer Applications, IGNOU. Semester 2. MCS 206 Object-Oriented Programming using Java. Block-2 Inheritance, Polymorphism and Packages. Unit-1 Inheritance. 1.0 Introduction. In the last unit of the previous block, you learned about class and objects. This unit takes you further in learning Java programming and will explain one important concept of object-oriented programming, known as inheritance. The inheritance can be known as one of the essential tools in object-oriented programming language, because it enables the reusability of properties of other classes. It takes advantage of the similarities that exist between various classes. It helps in data generalization and code reduction. If we look at the history of inheritance, it was invented in 1969 for Simula, a programming language, and is now being used throughout many object-oriented programming languages such as Java, C++, C#, and Python, etc. 1.1 Objectives. After going through this unit, you will be able to times explain basic concepts of inheritance, times write programs using the constructors along with inheritance, times apply access specifier concepts in hierarchical inheritance, and times use inheritance in solving complex programming problems. 1.2 Basics of Inheritance. The basic idea behind inheritance in Java programming is to enable the programmer to create multiple new classes that are built upon existing classes. When these new classes inherit the existing classes, then you can reuse the methods and fields of the parent class. Moreover, as per requirement, you can add the new methods, functionalities and attributes to your new class, inherited class. Inheritance represents there is a relationship which is also known as the parent-child relationship. The syntax of Java inheritance. Class child class extends parent_class. Fields methods. In the syntax, you can see the child_class is created using the keyword class, and it inherits the properties of the parent class with the help of the extends keyword. And other additional methods and fields also can be created as shown in the syntax. In general, the child class is known as subclass, and the parent class is known as superclass. Figure 1 shows a real-life example in which the child inherits the properties from their parents. A child will have the feature of its parents as well as its own features. In programming context, you may understand it in a way where code written in the parent class is available to the child class, and there is no need to write that code again. This reusability of code not only minimize the effort in applications development but also save a lot of time and resources. The objective behind inheritance in Java is to create new classes built upon existing classes, i.e., new classes will be able to use the attributes and methods of already existing classes. Inheritance facilitates reuse of the methods and fields of the parent class. Moreover, you can also create new methods and fields in the new class as per requirement. It also facilitates the programmer to achieve runtime polymorphism and code reusability. This indicates that there is no need to write the same code again and again while using it in other classes. About polymorphism, you will learn in the next unit of this block. For showing the inheritance, there must be at least two classes. The class which inherits the methods and data members fields from parent class is known as a subclass, child class, of the class from which it inherits, and the class from which subclass is inherited is known as a base class or parent class. Figure 2, Class Hierarchy. In Figure 2, Class B, Class C, and Class D, which are known as sibling classes, inherit the properties of Class A. If a class, for example, Class B is a subclass of Class A, then we say that Class A is the superclass of Class B. Sometimes, we also use the term derived class and base class instead of subclass and superclass respectively. Inheritance can be carried to several generations of the classes, as shown in Figure 2. Class E is a subclass of Class D, which is also a subclass of Class A. In this case, we can also consider like Class E is a subclass of Class A, even though it is not a direct subclass. This whole phenomenon of classes representation is known as a class hierarchy. The fundamental idea behind inheritance in Java is to enhance code reusability by inheriting the methods and fields of parent classes. In Figure 3, it is shown that the electronics class is the parent class for the child classes, phone, and sound system, which indicates that these two classes will have the properties of electronics class. Similarly, mobile phone and landline classes are deriving the properties of the phone class, which is treated as a parent class, and stereos and earphones are treated as a child class of the class sound system. This class hierarchy is moving from general to specific. In Figure 3, electronics is the most general class while the classes at the bottom are the most specific. Let us discuss the programming aspects of inheritance of Java with the help of a simple example in which vehicle is a parent class and four-wheeler is a child class. The child class inherits the properties of the parent class with the help of the extends keyword. 1.3 Advantages of inheritance. One of the biggest advantages of inheritance is that the code already mentioned in the parent class does not need to be rewritten in the child class, because child class may use the code without rewriting it. Another advantage of inheritance is like it can save time and effort because of code reusability. It also minimizes the development and maintenance costs because of the clear model structure, which is quite easy to understand. It is also possible to keep some data private in base class, which derived classes cannot use. In addition to the points mentioned above, you may consider the whole application. Development in context of inheritance represents there is a relationship, also known as the parent-child relationship. When you are designing a system, you may consider some features that will be inherited accessed from the parent's classes, and some features which need some special implementation may directly be implemented in a derived class. More details about the implementation of this philosophy will be discussed in the later section of this unit and also in the next unit of this block. 1.4 Member access and inheritance. Access modifiers are simply keywords in Java programming that provides accessibility of a class and its members. In Java there are four types of access specifiers, that is public, default, protected and private. These access specifiers are used to control what parts of a program can be accessed by whom. Well-defined set of permissions can prevent unauthorized access and misuse of data. Out of these access modifiers, protected is accessible within package and outside the package but with the help of implementing inheritance feature only. While public and private are like, when a member of a class is declared private, it can be accessed by other members of the class only. The public access specifier makes data members and member functions accessible outside of the class. That is why the public modifier has always preceded the main method, because it is called by code that is outside the program. In case when no access modifier is used, then a member of the class will be public within its own package but cannot be accessed outside of its own package. Examples for declaration using access specifiers are given below. Public int num, private int age, private int my method, int a, char b. Further, if we look at in terms of inheritance, a subclass includes all of the members of its superclass, but it cannot access the superclass members that are declared as private. Let's have a look at the below given example. Asterisk dash in a class hierarchy, private members remain private to their class asterisk. It is a superclass. Class A, int I, private int j, void setage, int x, int y, I is equal to x, j is equal to y. System out println value of I is plus I plus and value of j is plus j. Asterisk dash dash is j is not accessible here in this class dash 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 asterisk. Class B extends a int total void sum. Total is equal to I plus j. Error, j is not accessible here as it is declared private. Class main. Public static void main, string, args. B bobject is equal to new b. Bobject. Setage, 15, 30. Bobject. Sum. System. Out. Println, total is, plus bobject. Total. This program will not compile because access of j inside the sum method of class B causes an access violation. Since j is declared as private, it is only accessible to other members of its own class only. 1.5 Types of access specifiers. If you have declared anything public, then it can be accessed in any other class and package, but it is declared as private, then it can be accessed in the defined class only. Whenever a member does not have an explicit access specification, it can be accessed in a subclass as well as in other classes of the same package. Protected members are the members which can be seen in the direct subclass of other packages. A summary of various access specifiers is shown in Table 1. Table 1 Summary of access specifier. Let's have a look at the example for private access specifier. In this example, you can see that there are two classes, property and car_main, inside the packaged test. In the property class, private member running is defined, and we are trying to use this method in another class, car_main. Packaged test. Public class property. Private string running. Packaged test. Public class car_main. Public static void main, string, args. Property object is equal to new property. Object. Running is equal to, I is a fast running car. System. Out. Println, property of the car is, plus object. Running. The program's output shows that private member, running, cannot be accessed in another class car_main in the same package. It concludes as the private member is defined. Now, if you want to access the private member of the class into another class of the same package, then it can be accessed with the help of the public method of the same class in which the private member is defined. For example, setProperty and getProperty are these two public methods. With the help of these two methods, private members can be accessed into car_main class, which is a different class. Packaged test. Public class property. Private string running. Public void set property, string running. This running is equal to running. Public string get property. Return this. Running. Packaged test. Public class car underscore main. Public static void main, string, args. Property object is equal to new property. Object. Set property, it is a fast running car. System. Out. Print, property of the car is, plus object. Get property. The output of the program. Property of the car is. It is a fast running car. In this example, you can see that set property method is used to set the value of the private member in the same class, and then, with the help of get property method, it is accessed in the car underscore main class. And you can see that the program executes successfully and shows the outcome. The example given below explains the concept of protected and public access. Specifiers. Packaged test. Public class animal. Public int leg count. Protected void display. System. Out. Print, I am a protected animal. Public void display to. System. Out. Print, I am a public animal. System. Out. Print, I have, plus leg count plus, legs. Packaged test. Public class pet dog extends animal. Public static void main, string, args. Pet dog PD is equal to new pet dog. PD. Display. Output of the program. I am a protected animal. Another example program for further clarification is given below. Packaged test. Public class main. Public static void main, string, args. Animal ani is equal to new animal. Ani. Leg count is equal to 4. Ani. Display to. Output of the program. I am a public animal. I have 4 legs. 1.6 types of inheritance. Java supports many types of inheritance. The table given below gives a summarized presentation of the inheritance supported by Java. Table 2 types of inheritance. Look at the screen. Java supports single inheritance, hierarchical inheritance and multi-level inheritance. But multiple inheritance is not supported by Java. Java provides the feature known as interface, which fills the gap of non-supporting of multiple inheritances. You will learn about interface in Unit 4 of this block. 1.7 Use of super keywords. Java defines a special variable named super. This keyword is used to refer to the objects of the immediate parent class. In general, super refers to the object that contains the method. It forgets about the objects of the class in which you are writing, and it remembers about the objects that belong to the superclass in that class in which you are writing. The super keyword does not know about the functionalities of methods and variables of the superclass. It can only be used to call to methods and variables in the superclass. The super has 2 general forms uses. The first one is to call the superclass constructor, and the second is to access a member of the superclass that a member of a subclass has hidden. 1st July 2001 Calling the superclass constructor. A subclass can call a constructor defined by its superclass by using the following syntax of super. Super, arglist. Here arglist indicates the arguments required by the superclass constructor. To see the use of super, consider the following example given below. In the given example, box weight class inherits the properties of box class. asterisk dash 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 definition of the box class dash 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 asterisk class box private double width private double height private double depth asterisk dash 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 constructor with all the specified dimensions dash 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 asterisk box double W double H double D width is equal to W height is equal to H depth is equal to D asterisk dash 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 constructor when dimensions are not specified dash 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 asterisk box width is equal to 1 height is equal to 1 depth is equal to 1 asterisk dash 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 constructor when box is in the form of cube dash 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 asterisk box double lay width is equal to height is equal to depth is equal to lay asterisk dash 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 method to compute the volume dash 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 asterisk double volume return width asterisk height asterisk depth class box weight extends box double weight asterisk dash 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 constructor with all the specified parameters dash 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 asterisk box weight double W double H double D double M super W H D asterisk dash 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 call super class constructor dash 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 asterisk weight is equal to M box weight super weight is equal to 1 box weight double lay double M super lay weight is equal to M asterisk dash 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 the main class implementation dash 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 asterisk public class superdemo public static void main string args box weight box 1 is equal to new box weight 20 30 25 54.5 box weight box 2 is equal to new box weight cube is equal to new box weight 5 7 double wall is equal to box 1 dot volume system out print volume of the box 1 is plus wall system out print weight of the box 1 is plus box 1 dot weight wall is equal to box 2 dot volume system out print volume of the box 2 is plus wall system out print weight of the box 2 is plus box 2 dot weight system out print wall is equal to cube volume system out print volume of the cube is plus wall system out print weight of the cube is plus cube weight system out print output of the program volume of the box 1 is 15,000.0 weight of the box 1 is 54.5 volume of the box 2 is 1.0 weight of the box 2 is 1.0 volume of the cube is 125.0 weight of the cube is 7.0 explanation in the child class box weight super call the constructor of the parent class as shown below super W H D dash 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 box double W double H double D super dash 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 box super lay dash 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 box double lay. When we review the key concept behind super is like when a subclass calls super. It calls the constructor of the immediate superclass. The super always refers to the superclass just above the calling class. This concept is applicable even in a multileveled hierarchy also. 1st July 2002 to access the member of the superclass. Another use of super keyword is similar to this, except that it always refers to the superclass of the subclass in which it is used. The general syntax to access the members of the superclass is as follows. Super member. Here, member can be either a method or an instance variable. Let's have a look on superclass animal and child class dog. In dog class, the sound method calls the sound method of the superclass with the help of super keyword. Class animal. Public void sound. System. Out. Print. The animal makes sound. Class dog extends animal. Public void sound. Super. Sound. System. Out. Print. The dog barks. Bow wow. Public class main class. Public static void main. String args. Animal my dog is equal to new dog. My dog. Sound. Output of the program is as follows. The animal makes sound. The dog barks. Bow wow. The above example was based on to access the superclass method. Now let's have an example based on to access the instance variable of the superclass. Asterisk dash 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 using super to overcome the name hiding dash 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 asterisk. Class A. Int I. Asterisk dash 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 create a subclass by extending class A dash 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 asterisk. Class B extends A. Int I. This I hides the I in defined class A. B. Int A. Int B. Super. I is equal to A. I defined in class A. I is equal to B. I defined in class B. Void show. System. Out. Print. I is superclass. Plus super. I. System. Out. Print. I in subclass. Plus I. Class main. Public static void main. String args. B subobject is equal to new B. 5. 10. Subobject. Show. Output of the program. I in superclass. 5. I in subclass. 10. So, you can see the instance variable I in B hides the variable I defined in class A. Super keyword allows access to the variable I defined in the superclass A. Also, you have already seen that super can be used to invoke the methods hidden by subclass. 1.8 Creating multi-level class hierarchy. Till now, we have seen a few simple examples of class hierarchies that consist of using a superclass and a subclass only. However, you can build hierarchies that can contain as many layers as you want. For example, given three classes student, marks, and percentage, as shown in figure 4. Percentage can be a subclass of marks, which is further a subclass of student. Figure 5 Multi-level class hierarchy. In multi-level hierarchy, each subclass inherits all of the properties found in its superclass. Class student. Int roll number. String name. Asterisk R and N are used to set the roll number and name asterisk. Student, int R, string N. Roll number is equal to R. Name is equal to N. Void show. System. Out. Print. Student roll number is plus roll number. System out. Println student name is plus name. Class marks extends student. Int S1 S2 S3 S4 S5 sum. Marks int r, string n, int m1 int m2 int m3 int m4 int m5. Super r n. S1 is equal to m1. S2 is equal to m2. S3 is equal to m3. S4 is equal to m4. S5 is equal to m5. Void show marks. Show. Sum is equal to S1 plus S2 plus S3 plus S4 plus S5. System out. Println total marks plus sum. Class percentage extends marks. Float percent. Percentage int r, string n, int m1 int m2 int m3 int m4 int m5 float p. Super r n m1 m2 m3 m4 m5. Percent is equal to p. Void show percent. Show marks. Percent is equal to sum 5. System out. Println percentage plus percent plus percent. Class main. Public static void main string args. Percentage p is equal to new percentage 1025 Sunil 90 85 80 88 75 0. P show percent. Output of the program. Student roll number is 1025. Student name Sunil. Total marks 418. Percentage 83.0%. In the above program, the three classes student, marks, and percentage forming a multi-level hierarchy. The student class serves as the parent class for the derived class. Marks, which in turn serves as a parent class for the derived class percentage. 1.9 Demonstrating order of constructors execution. Constructors in Java are similar to methods that are invoked while creating an object in the class. In general, the order of constructor execution depends on the order in which the class hierarchy of the classes is created. In a class hierarchy, constructors complete their execution in order of derivation, from superclass to subclass. For example, given a subclass parents and a superclass grandparents, constructor executed before the parents. Class grandparents. System out. Println inside grandparents constructor. Class parents extends grandparents. Parents. System out. Println inside parents constructor. Class child extends parents. Child. System out. Println inside child constructor. Class calling constructor. Public static void main string args. Child C is equal to new child. Output of the program. Inside grandparents constructor. Inside parents constructor. Inside child constructor. It can be seen in the above example that the constructor execution is in the order of derivation. If you think that this order makes sense, it is because a superclass has no knowledge of any subclass. Therefore, any initialization it needs to perform is separate from and possibly prerequisite to any initialization performed by the subclass. Therefore, superclass constructor must complete its execution first. 1.10 Use of final keyword. The final keyword in Java is to restrict the access of its contents from being modified. If any field is declared as final, it means that the field cannot be modified and will become essentially a constant. This declaration can be made in one of two ways. First, you can give it a value during declaration, and second, you can assign a Value within a constructor. Assigning value while the declaration is one of the most common practices. For example, final int num is equal to 1. The final keyword is quite useful when you want a variable to always store the same value throughout the program. For example, final double pi is equal to 3.14. The final keyword can be used along with the variables, methods, and classes like final variable, final method, and final class respectively. Class bike. Final int speed limit is equal to 90, asterisk dash 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 final variable dash 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 asterisk. Void run. Speed limit is equal to 200. System. Out. Print speed limit is plus speed limit. Public static void main string args. Bike is equal to new bike. Bike. Run. Output of the program. Error. Cannot assign a value to final variable speed limit. There can be a case of the final blank variable when it is not initialized during declaration. Then it is a must to initialize in the constructor of the class, otherwise, it will throw a compile time error. For example, class blank underscore test. Final int I, blank underscore test, int kiss smiley. I is equal to x, asterisk dash dash initialization of final variable inside the constructor dash dash asterisk. Class main class. Public static void main, string, args. Blank underscore test bt1 is equal to new blank underscore test, 15. System. Out. Print, value of I is, plus bt1.I. Output of the program. Value of I is, 15. Use of final keyword with the variables are stated above. Now other two uses, i.e. with method and class apply to inheritance. Using final to prevent overriding. Overriding in Java is one of the most powerful features. There will be times when you will want to prevent it from occurring. If you want to disallow a method to be overridden, mention the final as a modifier at the beginning of its declaration. The method declared as final cannot be overridden. Look at the example given below. Class RAM. Final void method 1. System. Out. Print. This is a final method. Class Ravi extends RAM. Void method 1. Asterisk dash dash error. Can't override dash 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 asterisk. System. Out. Print. Illegal. Method cannot be overridden. Output of the program. Error. Method 1 in Ravi cannot override method 1 in RAM. Because method 1 is declared as final, that's why it cannot be overridden in Ravi. If you will try to do so, it will give a compile time error. Using final to prevent inheritance. Final keyword can also be used to prevent a class from being overridden. To do this, start the class declaration with the final keyword. Doing this, it implicitly declares all of its methods as final. Final class RAM. Asterisk dash 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 class RAM is declared as final dash 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 asterisk. Void method. System. Out. Print. This is a final class. Class Ravi extends RAM. Void method. System. Out. Print. Ravi cannot inherit the class RAM. 1.11 Summary. In this unit, we have discussed the concept of inheritance, which is one of the important feature of object-oriented programming. This unit explained how to derive the properties of one class into another class. We also discussed the access specifiers of data members along with a comparative summary also in the unit multi-level class. Hierarchy has been discussed. A few key terms like super, final, and this are also discussed. Also in this unit, demonstration of constructors calling has been discussed. Thank you. Subscribe to our channel for more updates, and we will see you with the next chapter.